Today, I'm presenting my project title Emergency Dispatch System using data structures. The emergency system, thousands of calls such as an medical emergency, fire accidents, and the police incident are received every day. These systems must process a quickly, prioritize an urgent cases, and retrieve the data efficiently. The main objective of this project is to analyze how a different data structures perform when handling emergency call data, visualizing the performance using graph. This output shows the performance of a benchmark results of the four different data structures used in the emergency dispatch system. The compression measures how an efficient each data structures perform three important operation: insert, adding a new emergency call; extract, retrieving the highest priority call; top k, retrieves the top k urgent calls. This experiment was performed within the three data sets like 1000, 5000 and 10,000. This time shows measured in milliseconds. Balanced binary search. The balanced binary search tree maintains an elements in sorting order while keeping the tree balanced. Insert operations are relatively faster for the smaller data set. Extract and operations are relatively faster to the smaller data set. Extract operations remain very efficient even as the dataset grows. At a dataset 1000, inserting took 0.63 milliseconds. At 10,000, insert increases a 7.1 millisecond. Hash map. The hash maps are designed for the faster key based lookup. Inserting operations are extremely faster. However, operations that require ordering or prioritizing becomes very slow. For example, inserting of 10,000 records only take 2.992 milliseconds, which is very efficient, but extracting a prioritized elements takes 1193 milliseconds, which is much slower. Prioritize query. The priority query implemented using an heap is specifically designed for the priority based operations. The extract operations are extremely faster because the highest priority element is always at the beginning. However, insertion becomes very slow because elements must shift to maintain the sorting order. The hash map is the best for the faster insertion and lookup. Sorted array provides a very fast extraction but extremely slow insertion. A balanced binary search tree provides a balanced performance across operations. Priority query provides the best performance for the priority based extraction. Then emergency call dispatcher system which prioritize handling is critical. The priority query implemented using heap provides the most efficient result. Heap is considered the best data structures for the relevant dispatch system because it is efficiently managed priority based operation. In emergency system, not all calls have the same urgency. For example, a fire accident or the heart attack must be handled before a minor issue. Therefore, the system must always process the highest priority call first. The heap, specifically a heap query implemented using a heap, automatically maintains an element in priority order. The most important property of the heap is that the highest priority element is always available at the top, which allows the system to quickly retrieve the most urgent emergency call. About the website, to make the analyzing easy to understand, and I have created a web-based visualization platform where performance graphs are displayed. The website shows a benchmark results for the different data structures when performing an operations on the emergency call dataset. The system comprises a multi-structures and visualizes the performance through graphs such as insert, delete, extract, memory usage. This allows us to clear understand which data performs a better for an emergency dispatch system. The time complexity of extracting the highest priority element in a heap is log n, which is very frequent efficient when handling the thousands of call. The highest, the most important priority of heap is the highest priority, which allows an system to quickly retrieve the most urgent call. Thank you.